Cool. All right. So see some new faces today. For those of you who haven't met me, I'm Justin. I co-founded XeroxPark. I work at Lattice on a bunch of fun stuff. And today I'm giving a talk I prepared in the last 5 hours about the missing Ethereum framework. So it's kind of a rant, but I think it's not going to be too crazy compared to the thing I usually rant about. So it's an accessible rant. So today, decentralized application developers essentially program bare metal. So what this means is they just write apps that interact with the EVM directly. Actually, some of the most respected developers are normalizing gas golfing. They're almost like living in the past. They're regressing. They're transforming something that will probably be abundant, or at least we should strive towards making it abundant and normalize it as a scarce resource. That goes away usually. And also those apps, more often than not, they're related to the own verb, to own things. So like Ethereum is the world's computer, or at least we hope it's going to be, and it spans a computational universe with which you can do anything. But today people just put things that have to do with owning stuff. And so they have this own verb and they make a bunch of things around the owning verb. There's like, oh no, I can lend something to you in like a vault with a pool and blah, 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 and dividends. And it's everybody's looking for the other verbs. But the thing is, the other verbs are hard. So one of the things that I think is hurting any form of innovation is that smart contracts, which are like programs running on Ethereum, they can't make any assumptions about other smart contracts beyond like just message understanding. So you know that like a smart contract has this thing called transfer from, and you can send it 3 things, and that's all you know about it, right? And sometimes you don't even know that. You're lucky if you know this. We have this thing called ABI, which is the application binary interface, as a standard format for understanding those entry points, so the language that those contracts talk, but that's it. And so we have tools that can surface those entry points, you can do things with it, but that everything else is kind of a black box, right? So you have bytecode, which is, you have a low semantic logic, so you have a bunch of opcode, so that's all you know about. Actually smart contracts can read other people's bytecode, there's contracts bytecode, but they can't do much with that. There is no way to actually extract any high-level semantic from this. And similarly with state, you have a key value database called a byte storage, but it's completely unintrospectable. There is not much you can do beyond that. So we have this world's computer with programs with the promise of composability, interoperability, whatever buzzword, but those programs barely know how to talk to each other. And so when we think about it, you have a smart contract, it's a box, and it's question mark, question mark, question mark, because you have no freaking idea what happens inside. And you have this little ABI thing, a bunch of pipes that have labels on them, and that's all you know about them, right? So this is how it looks like. That's the bytecode, the contract, that's all you can see. And this is the key value store. That's all you can see as well. That's it. Now go do something amazing with that. So actually, one more thing about this. It's not a surprise then that most of what we've been doing in this ecosystem is agreeing on a bunch of interfaces, which are just like message formats. Actually, I was looking at the list of EIP and ERCs, and I think 50% of the ones that are finals that are considered to be accepted are about money, are about owning things. It's owning contracts, owning money, owning like derivatives, whatever. And kind of like beyond the fact that Ethereum is like kind of like was built in an age where Bitcoin was the thing that mattered, right? Like they built the world computer almost by mistake. Not by mistake, but like they didn't plan on doing that first. They were like, oh, what if we do Bitcoin with like some programs? So it's not a surprise that it's mostly about owning things, but it is kind of, I think, surprising that even 6 years in, we haven't gone much beyond that. And even when it comes to interfaces itself, we can only talk about things that like, we can talk about nuggets of things you can own essentially. So, and it's actually very similar to early web server development. So, it's more like 25, 30 years ago, servers could talk HTML, SOAP, XML, like REST wasn't invented at that time, nor JSON. But beyond messages or beyond the things they were talking, there were no real standards. They were just libraries. So you're trying to write Yahoo, you just sit down and you write some C++ code with some libraries that talks HTML, and that's it. right? You just like return some data to people. Mark Andreessen got really rich by building the Netscape server, which was a standard way to serve HTML. But at that time, everything was essentially rolled down from scratch. We just had the messaging interfaces. And it's uncannily similar to the situation we're in today. So most on-chain applications are built from scratch with the help of core libraries. And people like just do, like even for core libraries, people like writing everything on their own because it's kind of cool, you know, it's edgy. If you can write everything yourself, you just import things like math because you're not smart enough to write those. But beyond that, you just roll everything yourself. You commit to some form of languages that you can talk, not to be confused with a programming language. You just talk a language because that's what smart contracts do. They talk to each other. You can say, hey, I can speak fungible tokens. My dialect is ERC20. And actually, before this thing called ERC165, smart contracts didn't even know what other smart contracts could talk. They were like, oh, like developers know that you can say that to those contracts because from outside the box, you can kind of like reach out on the internet to be like, hey, does this thing talk ERC20? But smart contracts themselves didn't even have any form of introspection in the system. All the tools we have operate at the level of bytecode and API. You need a vast amount of expert knowledge in order to be able to make those things. And there's a tight coupling of data and logic that led to massive upgrade-induced hacks. So, you know, smart contracts are immutable. You can't change your code, but you can still upgrade them because there's some tricks. But the thing is, because people merge logic and data together, sometimes they do catastrophic things that blow hundreds of millions of dollars. Actually, the amount of effort and energy that has just been spent on this single problem, like how do we upgrade smart contracts? You have proxies, diamond standard, like all of OpenZeppelin's business has been built on how do you upgrade stuff without losing all of your money. It's insane. So today I want to talk about Ruby on Rails. So Ruby on Rails is 18 years old. It's like in the history of like normal, like just internet, just Web 2, that's how people call it. Ruby on Rails, when it came out, was an instant hit. It was focused on developer experience and developer speed at the cost of freedom. So Ruby on Rails, just to give some context, it's a web framework that is built on top of Ruby. It was the first web framework. So Django, Laravel, Phoenix, which are like new web frameworks, are all inspired by Ruby. And Ruby still powers many, so Ruby on Rails. Ruby on Rails, or ROR, like it's just very mouthful. Ruby on Rails powers most of the big websites today, like Airbnb, GitHub, Twitch, Shopify, Stripe, more. Twitter used to run on Ruby on Rails. And then they moved to something else because Twitter is really hard to run at scale. You have to roll everything yourself. And it's pretty interesting that even massive businesses like GitHub didn't roll out their own solution, right? Like, why did they choose Ruby on Rails? Well, the thing that's interesting with Rails is that it constrains you in a format that says, here's how you access your data, here's how you do X, here's how you do Y. But in exchange, you get an immense amount of speed and good developer experience, and also a lot of free features. So that's the Ruby on Rails creator on the release of Ruby on Rails 7 said, the part that really excited me about this version though is we're much closer, it brings us much closer to the ideal of the one-person framework. A toolkit so powerful that it allows a single individual to create modern applications upon which they might build a competitive business the way it used to be. So it's all about empowering people. And if you build apps with Ruby on Rails, it's a framework that forces you, like the developer, to store data, logic, and permission in a standard way with a bunch of like Ruby on Rails technologies called active records, and there's like the wire thing, a bunch of stuff. But after having paid this freedom where you can't just do whatever you want, you get so much stuff for free, right? You get speed at the design stage because you don't have to make any decisions. Like, here's the way it's done. Ruby on Rails embraces this thing called convention over configuration. You never configure Ruby on Rails, you just do the thing that everybody else does. And that's what this thing understands. You have Rails code. As an example, with Ruby on Rails, you never have to deal with databases because it has an ORM. Actually, Ruby on Rails invented the ORM. Instead of writing SQL queries, just like, tell us how your data is and we're going to figure it out. And you get a bunch of free features. So as an example, when you use Ruby on Rails, you get a no-code admin panel. You start your app, you have an admin panel out of the box. Today, you have to pay like even in the web today, I think we actually regress compared to Ruby on Rails. Today, you have to like install like 500 libraries and like maybe even pay people to get your free admin panel. So Ruby on Rails was quite interesting. And here's a bunch of statements about Ruby on Rails. The first one is when it gets faster, your app gets faster for free. You don't have to change anything. Like, given you only wrote a tiny amount of your app and the rest is just Ruby on Rails in its general, you have thousands, if not tens of thousands of people that invest money into making it faster. So every time it gets faster, your app gets faster for free. When it gets new features, your app gets new features. When the admin panel gets better, you just get a better admin panel as well. Developers can move from one Ruby on Rails code base to another very easily. It actually became a job to be a Ruby on Rails developer because the conventions are the same and the system hides the same part of the code base. Similarly, consuming a backend, so let's say you build a front end, it's really easy because there are a bunch of things that have been written for you by plenty of people in the world. Given Ruby on Rails gives you introspections and standard data retrieval, like it's CRUD, it's graph-based and so forth, you have a bunch of libraries that makes it such that you get your data on your front end easily. You don't have to like reinvent the wheel 100 times. So when are we going to see the first Ethereum framework, right? Like it has been 6 years, people have like reinvented everything like 20 times. Actually, I Googled Ethereum framework and all I get is like developer frameworks like Hardhat and Foundry, but there's no Ruby on Rails of Ethereum today. So here's a small segue into the software engineering abstraction ladder. So usually you have instruction sets or virtual machines. That's the interface you have with the hardware, for example, RISC-V. That's like for like traditional computing, RISC-V or like x86. And you have programming languages that compile to that instruction set, and then you have frameworks that run in those programming languages, right? For Ethereum, we have a single VM, this is EVM, with programming languages, Solidity, Hop, Viper, but we have no framework, right? And I think it's really surprising that we haven't seen something like this yet. And my intuition is that it wasn't really needed so far. Actually, it wasn't needed for the first 2-3 years, but then we got into this weird loop where nobody thought we needed a framework. So nobody built one, and people kept building the things that you could do without a framework. And then now people are reinventing the same application 100 times in a row. There's this crazy circle jerk of like, oh, we're going to make this thing faster and we're going to code goals that thing. And I think it's really, really regressive. And so the other thing that is very surprising is because we don't have a framework, the people building Ethereum, they're putting things that shouldn't be in the framework in the actual language or in the VM itself. Like things like ABI.encode shouldn't be in Solidity. Like this just doesn't make sense that it's baked in the language itself. Off call, account abstraction, like all of those things, like even the timer opcode shouldn't have to be in the VM itself. That should be exposed at a framework level. So because we don't have this, people are trying to put things that shouldn't be in that abstraction, that like in that step of abstraction, in that level of abstraction in it, because they have no other places to put that thing. And actually, know what happens is you have companies that come in and they take a tiny slice of what a framework should be and they try to like sell it to other people or like create a token of it. Like the gas station network shouldn't be a thing that it's on its own and that people are trying to get everybody to use. It should just be part of a bigger framework. And so what do, right? So unsurprisingly, if you know me, I claim that this thing we've been collectively building together that was first described as an engine for autonomous world is actually just like an engine for everything on chain. And it started as something for video games, and it's actually what happens every time. You discover that it's way more general than it actually is. Yes, you can take pictures. So I claim MUD is the missing Ethereum framework, and it's our last hope for a proper application stack. So I'm going to talk about two things: MUD for developing on-chain apps and why I think it's very close to Ruby on Rails, and also MUD as a fertile ground for a vibrant ecology of programs. It's a very fancy way of putting some stuff together. Anyway, so MUD is actually very similar to Ruby on Rails. It brings convention over configuration, right? Like you have a way you have to organize your files when you use it. A standard data model. You can't store the data however you want. We actually enforce on you a way to store your data. There's introspection. So actually contracts and things off-chain know how to understand the data in your smart contract. It's not just a bunch of bytes with a key value store. We actually store schemas on-chain and they can be consumed. There's a standard way to load that data into consumers. So the people here that have built stuff on MUD, they didn't have to write any network code in their apps, right? They just like, if you have used Firebase before, you know, like the Web2 world, you just write the queries and the data you want and just get it. You don't have to do everything like all the other stuff. And you get deployment and migration tools. Like just a single thing, the fact that in MUD, logic and data is separated is probably going to save hundreds of millions of dollars because people are not going to put those things together and then screw themselves up. And it's like Ruby on Rails because it's opinionated. So yeah, first thing, MUD forces you to separate code and data. So this is how people do it in the same world. They have their logic into like a shady thing written by their engineers. They have their data in a database that was written over like 20 years by really good people on the internet with a long beard. And this is the thing they change. They don't change that because if they change that, they risk losing all their data because that's the hard part. But the thing is, with the people that build on top of the EVM, they put everything in the same box. Like storage, permission, structured data, logic, ACL, all of that stuff is together, and that just leads to a lot of errors, right? So if you separate those two things, which mud forces you to, you get no upgrade bullshit. Like people, as I said, people in the ecosystem spend way too much time on proxies, upgrade systems, storage contract, all that stuff. If you separate logic from data, now you can swap your logic, and the data contracts with the models and the access control lists are immutable. You can't change them, right? You can lay down migration paths if you want. They shouldn't be upgradable. I'm noticing this talk is getting really technical, so sorry about that. MUD brings conventions to code bases and the mental model of the developers with those things we call entity component systems. That comes actually from the video game industry. Turns out ECS is just SQL. An entity is just a primary key, a component is a table, and a system is a procedure. So yeah, it's the ORM of MUD. This is the active, like in Ruby on Rails, that would be called the active record. So the benefit is that developers can understand your code base easily, right? And so can auditors. Because they don't, if they see you access data the way you're supposed to with MUD, with the query language and stuff like that, and you write it the same way, they don't have to audit all the data access thing, which is usually one of the things that has critical bugs. They just have to audit the state transitions, which is much easier. I put the huge stack here because it's really important. MUD standardizes your data model. So when you write smart contracts, people before they would just they would just make shit up when it comes to how you store your data. They're like, oh, I'm gonna make a mapping between this and that, and a reverse mapping there and an array of stuff, and that's how I'm storing my data. And another contract will do it in a different way, and another contract will do it in a different way. This is why we have this thing called the graph, where every single person has to write an indexer themselves, because they have to teach the program, here's how you understand my smart contract. If you standardize your data model, you don't have to do that. So MUD enforces a way to model and store data, and it comes with a standard query language for reading data and soon for writing data. So that's from our talk in Bogota. So if you want to make, this was in the context of a game, but if your natural query is like natural language queries, give me all movable attack entities owned by this address. This is how you would express it. This is actually valid solidity. You can send that to a contract that uses MUD, as long as you know that those components have been defined, which you know because you can do introspection and it's going to tell you. Compare this to like interfaces we have today, where it's actually not queries, it's just RPC calls. It's like, oh, I can ask who's the owner of this NFT or this token, but there's a specific thing that is given to me, but I can't make general statements or questions about the way the data is stored and like what is actually inside the data itself. And as an example, let's say you store position in MUD, like this is a thing, this is a component, it's a table. Those things are self-descriptive. So they have a schema on chain that other contracts know about, and like front ends and clients know about, that they can use to decode that data and access it. So not only can you make a query to ask, hey, can you give me the position of all the things owned by Arthur that are red? When you get those pieces of data, you can actually go inside them and get the X value because you know how to decode it. Whereas with other smart contracts, you would just get a bunch of bytes and then good luck knowing what's going on. You would have to write the way to decode it by knowing ahead of time how to decode it, right? So in a normal contract, what you actually have is just a key value store of bytes. In MUD, you have keys, which are entities. Entities can just be anything, they're just primary keys. And you have components attached to them with values. If you want to think about it like a database, it's like this. You have two tables, position and health as an example here. You have different rows with different columns, and that's what it is. So the benefits that you have standard read-write interfaces for everything, auto contracts, clients, indexers. This is how it looks like today. You have a program that is incomprehensible. And then you have another program that wants to talk to it. It has to send calls via the EVM. The only way for that program to know how to talk to that one is for the programmer that programmed it to actually know what that program talks and put in the code itself. For the client, the indexers, they have access to this thing called the ABI, but after that, they have to do a bunch of work as well. The indexer has to map every single thing that comes out of this contract to something that changed the data model, and it has to define the data model itself. So for anyone here that's written a graph like indexer or like subgraph, that's how they call it, you have to define the same data model that is here, just a new again, basically. And you have to write again on your state transitions. Similarly with the clients, this is why something as simple as Uniswap has a crazy code basis just to be able to use it, because they have to re-implement the entire protocol in the browser. And this is how it looks like with MUD. Sorry, it's really small, but you have this like rich, semantically heavy data. You have mutations. You have access controls list, and they can be consumed from another contract via queries. And Clients and indexers, they just speak the mud protocol, right? The indexers, you actually don't have to write any code. If you spin up a mud indexer today, you connect it to a world, and that's it. You don't have to do any work. You can just query it afterwards because it already knows the data. It knows how to understand it. It knows what the relationship between the data is. Similarly with the client, it's the Firebase-like experience. You add 5 lines of code, and then you know about all of those things with types, and you can react to them changing over time. This is the Ruby on Rails admin panel you get for free. It's not very pretty, but it works. We have something like that in Mud. We have just like a component explorer, and that's just the beginning, right? Maybe in the future, we're gonna get something like this. It's even harder to read, but that's a full-on database editor, right? Those are the things you get when you standardize things. When you sacrifice freedom, you get features. But you can't do that at the language level or even at the protocol level, because that's extremely political, right? So you have to do it at a level of abstraction that is higher than that. So I don't know, a bunch of other claims. When Mud gets faster, your app gets faster too, right? Mud right now is really gas inefficient because we didn't care about this, but like everybody here wants to make it faster, right? So we can make it faster. We can make it more gas efficient. And the thing is, given Mud takes care of like data retrieval, modeling, and writing, improvement in gas efficiency there makes every app faster, of course. But the thing is, that's where most of the cost comes from in any app anyway. It's reading and writing data. That's the most expensive thing in the EVM. And so this is kind of similar to how like when Solidity ships a new version that generates better bytecode, it makes all the new contracts cheaper. But the thing is, Solidity is really slow because it's political. And also it has to cater to like a very large amount of use cases. Whereas here, we can kind of create like a little conspiracy where we make things faster just for ourselves. And again, when it gets new features, your app gets new features. So free features. Well, today, the L1 and the L2s and the languages, they're actually pushing to put features into themselves, which is like, as I said, slow and prone to politics. Things like account abstraction, permit by signature, on-chain schedulers, async await, all of that stuff should be implemented at the framework level. It should be implemented at the language or the VM level. And today, like, there's so many companies and groups that like PvP that fight against each other in order to get the developers to use their thing instead of someone else's thing. But you can just kind of like put whatever you want in Mud and everybody's going to use it, right? So we can kind of like roll out those things ourselves, avoid the VC funded company that have a token to shill and just like make something open source and put it in Mud, and then you get it as well. And then the last little bit of rant is about a vibrant ecology of programs. So my claim is that composability within Ethereum, even if it seems like it, has not been a roaring success. People think it has been a roaring success. I think it's pretty embarrassing. It has been significantly underused. Someone just joined the call and did some weird echo stuff. It's significantly underused because we rely on message passing as the de facto interaction between things. And as I said earlier, like message passing is hard. You need to understand, you need to know ahead of time what language the other things talk, right? So speak. So today, how does contract A and B interact? Well, either B is deployed after A and the engineer read the code of contract A and they put their own like human specific knowledge into contract B in order to interact with A, or they communicate via an interface, kind of like ERC20. But B can't go well beyond the interface. It can't introspect A, it can't query arbitrarily A. And so I think that beyond making it easier to build Ethereum apps, which is what Ruby on Rails did, like in our example, like 20 years ago, we can collectively execute on the promise of composability inside the world computer if we make Mud better. And so it's like, instead of one on-chain app built with Mud, like all apps should be built with Mud, or at least talk the Mud query introspection language. Because then like you get this incredible effect where you're not blocked by the things that like the people that wrote the contract said you could learn about the system. You can learn anything you want. So come collaborate. This might be a bigger deal than you think. It's not about putting Minecraft on chain or like piss, arson, whatever. This is Arthur's game. I think it goes well beyond that. The reason why people are using it for games right now, it's because games are the most complicated applications on Ethereum. But if we make it easier and if the scaling people deliver on their promise of like making block space be abundant and gas price go to zero, then we'll need to jump up a level of abstraction. And I think we have something there. It was almost unintentional, but it becomes clearer and clearer every week that this at least is one of our last hope for a proper application stack.